Did you know that Earth isn't the only planet in the solar system to have clouds? Interesting, huh? Even on the red planet, there are clouds. Astronomers are aware of this, and they have found a strange cloud, a long one about 1,800 kilometers, that acts weirdly. Every few years in the spring or summer, this curious cloud returns before disappearing once again. Its pretty unique behavior really intrigued astronomers all over the world that was trying to explain the formation of that cloud and its disappearing. But now we seem to have an answer. Ladies and gentlemen, fasten your seatbelts because we are going to talk about the resolution to one of the strangest mysteries of Mars. Return of the elongated, mysterious cloud on Mars, 1,800 kilometers. With a human mission to Mars somewhere on the horizon, the planet is being scrutinized more than ever before. Currently, 8 orbiters are operating on the planet and some surface missions. As of February 2021, there are 2 operational rovers on the surface of Mars, the Curiosity and Perseverance rovers, both operated by the U.S. space agency NASA. A third rover, part of the Tianwen-1 mission, is currently attached to its orbiter and is planned to land in May of 2021. All of this just to say that if a cloud with a trail of about 1,800 kilometers suddenly emerges, it's pretty easy for us to spot it. In fact, in 2018, a camera on board the Mars Express mission caught sight of a strangely long and wispy cloud billowing across the surface of the red planet. From a distance, the 1,800-kilometer trail of fog almost resembled a plume of smoke, but it wasn't, and it seemed to be emerging from the top of a long-dead volcano, a unique scenario. Looking back at other archived images, researchers soon realized this actually had been happening for a while. Every few years in spring or summer, this curious cloud would return before disappearing once again. The fleeting plume was caught on camera in 2009, 2012, 2015, 2018, and again in 2020. A newly published study has now detailed the reasons behind why this long cloud keeps coming and going on Mars. To do this, researchers compared high-resolution observations of the 2018 plume to other archived observations, some of which stretch back all the way to the 1970s. Here's the cloud story. Each year around the start of spring or summer in the southern Martian hemisphere, the Arsia Mons elongated cloud begins to take shape. The southern solstice is when the sun is in its southernmost position in the sky. Since a Martian year is about twice as long as an Earth year, 687 days compared to 365, the seasons last about twice as long. This cloud grows each morning during the season for about 3 hours, then it disappears. We want to say it again. This cloud grows and disappears daily. The massive extinct volcano that is home to the cloud is Arsia Mons, a 20-kilometer high, 12.4-mile landmark on Mars' surface. But what's the difference between Mars clouds and Earth clouds? On Earth, clouds are made from water, whereas on other planets, they could be made from different substances such as methane, such as on Saturn. Earth clouds are created when the water on the ground, sea level, is heated and evaporates into the upper atmosphere. When the water reaches a certain height, depending on environmental conditions at the time, will group with other water to form clouds. When the pressure dips, the clouds begin to break up in the form of precipitation, rain, sleet, snow, hailstorms, and fall to Earth. The fallen water drops will eventually go back up into the atmosphere to form new clouds. Mars instead is too cold for liquid water, so the clouds are made of water ice. Though it looks like it could be a plume from the volcano, it's not. All of Mars's volcanic activity ceased a long time ago. Talking about our beautiful and mysterious Martian cloud, at dawn, dense air from the base of the Arsia Mons volcano begins to climb up the western slope. As temperatures drop, this wind expands and the moisture within it condenses around particles of dust, creating what here on Earth we call an orographic cloud. Do you know what an orographic cloud is? Before we answer that question, be sure to like or dislike the video, so that we can continue to improve and make these videos better for you, the viewer. Plus, be sure to subscribe to the channel by clicking the bell so that you don't miss any of our weekly videos. Orographic clouds develop in response to the forced lifting of air by the Earth's topography, mountains for example. Air passing over a mountain oscillates up and down as it moves downstream. If the air lifts upward and cools through expansion as it rises to its saturation temperature during this process, the water vapor within condenses and becomes visible as a cloud. Upon reaching the mountaintop, the air is heavier than the environment and will sink down the other side, warming as it descends. Once the air returns to its original height, it has the same buoyancy as the surrounding air. However, the air does not stop immediately because it still has momentum carrying it downward. With continued descent, the air becomes warmer than the surroundings and begins to accelerate back upwards towards its original height. It is during the uppermost descent phase of this cycle that clouds develop. In regions where the air is descending, skies are clear. The lifting of moist air can result in the generation of clouds, while lifting drier air may not produce any clouds at all. The oscillations continue as the air moves further downstream from the mountains, but are eventually dampened out by mixing and friction. Each morning, over the course of several months of observations, researchers watch this process of growth and disappearing repeat itself. At about 45 kilometers altitude, the air begins to expand, and for the following 2.5 hours or so, the cloud is pulled westward on the wind, as fast as 600 kilometers per hour, 380 miles per hour, before finally detaching from the volcano. At its largest, the plume can reach 1,800 kilometers in length, more than 1,100 miles, and 150 kilometers in width, nearly 100 miles. By noon, when the sun is at its apex, the cloud will have completely evaporated. In this case, both the pressure from underneath as well as the temperature needed to be very specific for these clouds to form and to stay in this cloud form for several hours. But once the temperature changes, or once all of this moist air disappears, the cloud dissipates as well. All of this happens pretty much every single day in the springtime and summertime, and then when the seasons change, all this stops happening until the next spring. What's interesting here is how fast all this happens. In fact, this happens in about 10 hours, which means that this cloud expands at very high speeds, up to 600 kilometers per hour. It is the speed of a flying airplane. In some sense, there are still a lot of different questions about this cloud and what exactly happens here. The other major question is why this particular mountain, and why this particular location? What makes this volcano so unique and so specific, and why doesn't this happen around other similar volcanoes in this area? If we look at the model of Mars, for example, you can kind of see that there are actually 4 major volcanoes here, but it is only this one, very close to the equator, that seems to have these effects. Also, not a single orographic cloud on Earth. Even the ones around Everest are as long, move as fast, or have such ridiculous dynamics. They don't change that fast. So whatever is happening here is actually an extreme of the solar system. Ice clouds are not exactly unusual on Mars, but the clouds above Arsia Mons continue to form in summer when most others disappear. Much of the time, this specific volcano has a cloud sitting on top of it, when others around don't. But only under some conditions does it spread out in a long streak. Each year at the start of winter, this cloud can also form a spiral. So if this long plume is happening daily for some time each year, why do we only have sporadic observations of it? Researchers say it's because many of the cameras orbiting Mars are only occasionally flying over this region in the morning, and observations are usually planned, which means we are often taking shots of this cloud simply by chance. Luckily, an old camera still on board the Mars Express mission, the Visual Monitoring Camera (VMC), which has the power of a 2003 webcam, has one perk newer technology doesn't. While other cameras on orbiters try to zoom in and get as much detail as possible, VMC is different. It's been described as a webcam in space, and its wide angle helps it see things like the cloud. Although the camera has a low spatial resolution, it has a wide field of view, essential to see the big picture at different local times of day. And it is wonderful for tracking a feature's evolution over both a long period and in a small time step. As a result, we could study the whole cloud across numerous life cycles. The study represents the first detailed exploration of the Arsia Mons cloud, and while scientists say it holds similar properties to orographic clouds on Earth, its size is enormous and its dynamics quite vivid in comparison to what we see on our own planet. Understanding this cloud gives us the exciting opportunity to try to replicate the cloud's formation with models that will improve our knowledge of climatic systems on both Mars and Earth, says astronomer Agustin Sanchez La Vega from the University of the Basque Country. Now that we know when the cloud occurs, it also allows us to direct other, stronger cameras in orbit to the right place at the right time, providing us with a closer glimpse. It may not be too long until the next pics. Before we wrap up this video, we want to recall that Earth and Mars are not the only two planets to have clouds. All the other planets except Mercury and probably Pluto, that's if you class Pluto as still being a planet, have clouds. Mercury doesn't have an atmosphere, so clouds can't form. At one time, it was believed that Venus was as hospitable to life as Earth is. Venus had water and may even have had life on it, but something catastrophic occurred and no known life exists. The clouds on Venus are highly acidic and trap the environment, keeping it warm and poisonous to any life. There is a theory that there might be microbial life in the upper clouds, but nothing too advanced. Also, all the gas giants have clouds in their upper atmosphere. The clouds on Saturn and Jupiter are composed of tiny ice crystals of frozen ammonia, ammonium hydrosulfide, and water. The outer gas planet Uranus and Neptune clouds consist of methane. How strange is the universe we live in? That's all for this video. Thanks for watching, everyone. Did you enjoy the video? Let us know in the comments below. See you next time on the channel.